All right, hey there. So now that you know how to cover up the 3D shapes, remember covering up would have been surface area. Now we're going to be focusing on filling up these 3D shapes, and filling up these shapes is called volume. So for definition, volume, it's the amount of space that fits inside one of our 3D shapes. And remember, another name for a 3D shape is a space figure. Okay, it's just a lot of space inside. Now for a rectangular prism here, when you've got a box, you're going to really like these problems. They're very, very easy. When finding length times width, y'all, if you do length times width, that's the area of this green bottom. But remember, we've given this some height. So that's why we're now going to multiply by the height, and we would have filled up this entire shape. So the formula that you guys see on your formula sheet is length times width times height. So anytime you have a box and we want to know what can fit inside of it, you're just going to use that formula, and you're just going to do the length times the width times the height. Now, because multiplication is commutative, it doesn't matter which order we multiply these in. I think of this as the length. I think of the 6 as the width, and the height here is the 3. So we're basically just multiplying a 6 times 4 times 3. So 6 times 4 times 3, it's going to be a 72. So to show it, you're just showing me that you're doing a 6 times 4 times 3, and we can put those in parentheses. And for the volume, we just said it's going to be 72. For the labeling here, we're going to put centimeters, and we put a little 3 up here because there's 3 dimensions now we care about, length, width, and height. So the way we say this, y'all, would be 72 cubic units. And I'll type that down just so you can see it. It's 72 cubic units. In this case, our units are centimeters, so I'm going to say 72 cubic centimeters. Okay, that's how that one is read. All right, cool. Now let's take a look at the second question here. So for number 2, the Goldbergs have a new 20-foot by 10-foot swimming pool in their backyard. If it has a uniform depth of 5 feet, how much water is needed to fill the pool? One thing I want to point out is that for swimming pools, there are swimming pools like the above ground kind, that are cylinders. And then we have the kinds that are in the ground that are rectangular prisms. And again, if you look at this from above, bear with me while I draw that box. Imagine that like this is the top part of the pool that you can see, and then you jump in, and this would all be the stuff that's underwater. Now I know for a lot of swimming pools, there's like a deep end and a shallow end, which is why this says there's a uniform depth of 5 feet. So the entire pool is 5 feet deep. Okay, so to draw this, let's actually start with a 20 by 5. This is going to be 20 across. And let's label the height here of 5. That's the depth of the pool. And now for the width of it to be a 10, let's just draw here these lines. And this is kind of a sketch of the swimming pool. And like I said, this part is technically underwater. We wouldn't be able to see this part. All right, it wants to know how much water is needed to fill the pool. And we can't forget about the 10 here. So now that we have kind of a sketch of what our in-ground swimming pool would look like, for the volume, we're just simply going to do the 20 by 10 by 5. So 20 times 10 times 5. And here we can see that it would be 1,000 cubic feet to fill this pool. 1,000 cubic feet to fill the pool. So for volume, you're just multiplying the 3 dimensions together. So the math here isn't too hard. It's actually a pretty easy topic. You're going to like these questions. Let's practice though with the tougher version of this is really just if I give you a blank shape and I give you the dimensions, can you take these and label the blank shape? So here you've been given the length, the width, and the height of each of these prisms. We're just going to label the drawing with the dimensions and then find the volume of each of these things. Since volume is such an easy topic where you're just multiplying the 3 numbers together, you'll notice that I've given you some decimals and fractions, and that's okay because we can always use our calculator to just multiply the numbers together. So for the first one, you'll notice that the length and the width are both the same, which means the length and the width, it's going to create a square. for the bottom. And we can see that square here. So for the length and the width, let's just go ahead and label a 4.7 for the length and then a 4.7. We've got the 4.7 labeling the length and the width. You could have labeled it up here if you wanted. You could have put a 4.7 here and then here. Doesn't matter to me. Does not matter to me. More traditionally, you see them labeled down here, so that's going to be what I leave for the notes. Now the height is the 16.2, which I think everybody agrees. The height is the 16.2. So now to find the volume, we're just simply going to multiply these three numbers together. So we're going to do a 4.7, oops, times 4.7. And that's the area of the base here. That would be the area of this square bottom. Now for volume, since it's a 3D shape, we now need to take this green area and multiply it by the height, which is the 16.2. So we did the square bottom, now just times height, so 16.2. And we'll round it. We'll let this 8 bump this up to a 6, so it'll be 357.86. 357.86. 357.86. And these were labeled with inches. So I'm going to put cubic inches. Friendly reminder that in the previous video, if we were covering up the shape, we would find the area of all these different faces and it would be square inches. But for volume, we've got the length, the width, and the height. So 3 dimensions, hence the cube. Okay, cool. All right, so for the next one, we have a length, a width, and a height. Now the height I think is always the easiest one to start with. So let's just label the height with the 6.3 feet. Okay, so we've taken care of the height. We've got that one. Now length and width, it really doesn't matter in terms of the formula because you're just multiplying the numbers. But let's talk about what makes sense. If the length is the 8.1 and this is the longer side and this is shorter, then this we'll label with the 8.1 just because it looks longer. So that's the 8.1. And then the width here would be the 2.5. Now to find volume, we're first going to do the 8.1 times the 2.5 because that'll be the area of this bottom rectangle. So let's do the 8.1 times 2.5, so length times width. So there's length times width. Now let's multiply by the height, so times 6.3. All right, we get 127, and we'll bump this to a, that'll be a 58, 0.58, okay, 127.58. And we'll label cubic feet. Cool, and now we're on the last one here. So we have a length, a width, and a height. Like I said, the height of these things, it's pretty easy to establish how tall these things are. So we have the height in green. We took care of that one. All right, now the length and the width. Again, it's up to you really how you see the shape, but mathematically we can see that this side is longer than this one. So this one gets to be the 6.5, and I'm just going to use a decimal. And then the width right here would be a 4 3/4, so 4.75. I'm just going to make that a decimal. The reason I make it a decimal is so I can now use the calculator to multiply. I've got the width here times the length times the height, and we're just going to multiply these three numbers now. So 4.75 times 6.5 times 3. All right, and this will bump it up to a 63. So 92.63. 92.63. This was inches, so I'm going to say cubic inches. So the volume of a prism, very easy. We're going to like volume of a prism. You're just multiplying your three numbers. And again, the reason we multiply the three numbers is because when you multiply the first two, it gives you the area of the rectangular bottom. And then when you multiply by height, you've now filled up this entire shape. All right, now we're going to switch gears and move over to volume of a cylinder. So if a cylinder has a circle bottom, it's going to be the pi r squared, and then simply times height. So you'll notice in this formula, the pi r squared comes from the area of the base. It's the area of this piece, so the pi r squared. And because we've given it height and we want to fill up a 3D thing, we're now going to multiply by height. All right, so for this cylinder here, the line all the way across is a diameter, and the diameter in this situation is 8. If the diameter is 8, we need the radius for our formula. So the radius is half of that. We're going to go with a 4. So to find volume, we're going to do pi. We're going to square the radius, and we're going to multiply it by height. Friendly reminder that the pi r squared, that would be the area of just the circle. But now since it's 3D, we're going to times it by the height. Pi is 3.14. We said the radius is 4. And the height of this thing is a 16. Now we just got to be careful to do the 4 squared first. PEMDAS says take care of your exponents first, so we get a 16. Cool, then we're going to multiply that by a pi, and then we multiply by the height, which is 16. So 3.14 times 16 times 16. So 803.84 is the volume of this cylinder. 803.84. And that was inches, so cubic inches. Now I'm going to open up Desmos real quick. Whoops, sorry, not a desk. Let's get the Desmos scientific calculator. And I'll remind you guys that you can tell Desmos, okay, I need pi, and I'm going to type in an r, which is going to get squared. So I've typed in pi r squared and then an h. Now I just need to tell it what the radius equals, and here the radius was 4. The height was also a 16. Okay. Now, do you guys see that if I tell it pi r squared times height, which is the formula, if I do the radius and the height, see how my answer is slightly off? And it's because it used pi, which goes on forever and ever. So if you are using Desmos, just do a 3.14 here and then tell it r squared and then h. And then you can just type in the radius and the height, and now you see it exactly matches the answer that we got. All right, I'm going to leave Desmos. Let's take a look at the next one, and we'll do the next one using Desmos. So you just bought a new pot, and you're going to plant a plant like in it. So the pot is shaped like a cylinder, and it has a diameter of 12 inches and a height of 1 inch. So let's draw this one, and this one's going to be kind of weird. Let's just start with kind of a really fat oval, because that distance all the way across is going to be a 12. And if that distance all the way across is a 12 and the height is only a 1, see how kind of flat that cylinder is meant to be? So if this is the 1, let's just pull the information we need from it. We need the radius. The radius is going to be a 6. It asks how much dirt will I need to fill this object. All right, we care about the radius and the height. So if I go back to Desmos, since it's still the volume of a cylinder, I'm going to leave that formula. And now this time we have a new radius and we have a new height. So if the radius is 6 and the height is 1, it looks like we're going to get a 113.04. A 113.04. Remember again, pi r squared would tell me the area of the circle. And then I'm going to multiply by h to fill up the 3D thing. This was in inches, so we're going to do cubic inches. And we're done with that problem. Now, like I said, once you have a formula and knowing how to use like Desmos for this stuff, it's actually pretty easy to get the right answers. You just got to be comfortable with how to read and label your shapes. So let's get comfortable and practice down here with how to label and read these cylinders given the different dimensions. All right, So for this one right here, we have that there's a radius of 8 and a height of 4.1. Now what we're going to do here is you've been given the diameter or the radius. We're going to match the dimensions to the correct cylinder. So for this one, you see how it wouldn't be this first cylinder? Because if the radius is 8, and the height is 4.1, we can see that this thing is supposed to be much wider than it is tall. So I would not put that this is an 8 on the first one and that this is a 4.1 because there's no way that makes sense. So we know it's definitely not the first one, that dimension set A. Dimension set A does not go with this cylinder. Now here, if I said the radius is 8, let's see if this makes sense. If I put an 8 here, that means this all the way across is a 16. Okay, the whole thing across would be a 16. Does this appear right here that it could be a 4.1? This right here is shorter than the 8, so this looks like it would work. This right here kind of makes sense. So let's go ahead and actually label this one. See how you've got your radius of 8 and then the height of 4.1? All right, so we've got dimension set A taken care of. All right, now dimension set B. The diameter all the way across is only a 10.5, and then the height would be a 13. So a 10 compared to a 13, and that's actually going to be this one, y'all. Right here, this 10 is a little bit shorter than that line right there, which is the 13. And sorry, it was a 10.5. So we've now labeled the diameter is all the way a 10.5, and then this is a 13, so we've labeled this dimension. And process of elimination lets us know, obviously, that this one's the one that's left. So diameter is 4 3/4, so the diameter across, 4.75. And then the height here would be a 14. And that definitely makes sense. So now what we've got here is 3 different cylinders. We appropriately labeled them, so now we just need to find the volume. Okay, so for this one, the radius and the height we need. For this one, the radius and the height we need. And for this one, the radius and the height we need. Now, why do I need radius and height? Because the formula says you need pi r squared times height. So if we know the radius and we know the height, we can find the volume. All right, so for this first one, if the diameter all the way across is a 4.75, let's just cut it in half. We've got the radius, 2.375. Okay, now the height is the 14. So now let's just use Desmos. We've got 3.14 pi, the radius squared, and then times height. That's the formula for volume. Now in this picture, my radius is a 2.375. The height in this one is a 14. So right there is my volume. It's going to be 247.96. 247.96. And this was in inches. We should put inches from the dimensions. So this would be cubic inches. Next one, very easy. Because the radius was already given, we have the 8. The height is a 4.1. So we can just use Desmos for that. All right, the radius we know is an 8 now. The height this time is a 4.1. So when I put in those dimensions, we get an 823.936. I'm going to use the 6 to bump this up to a 9.4. So 823.94. 823.94. And this matched dimension set A. These were inches. So we're going to say cubic inches. All right. And last but not least for this one, the diameter all the way across is a 10.5, so let's cut that in half to be the radius. So the radius is a 5.25 for this one, 5.25. The height is a 13. So if I give you the diameter and the height, just get the radius, and you've still got your height, and you're ready to use Desmos. So the height for this one we said was the 13. The radius is a 5.25. All right, cool. So the volume of this cylinder is 1125 point. And then see how I've been going to the nearest hundredth? So 10. So 1125.10. 1125.10. And this was cubic feet because these were labeled feet. So 1125.10 cubic feet. So you've got a formula. Friendly reminder that the formula, area of the base times height. It worked over here because the base was a square, so then times height. And now you're ready to move over to the next page and practice finding volume of each of these figures on your own. Don't forget that you already watched a video a little while ago on for volume of these things that you're basically just counting the number of cubes that you see. So for this one, I see 1, 2, 3, 4, 5, 6, 7 cubes, 8, 9. And these two have to be on top of another cube. So this one, for example, I can already tell you that's going to be 10 cubic units. You just literally count how many boxes you would even see. And if there's something on top of it, don't forget to count the one underneath it, okay? All right, that concludes this video. Thank you for watching.